Handling and using the torch is the most fundamental of all skills needed to perform TIG welding operations. The torch should be held with a relaxed grip in the manner demonstrated. Many welders use their fingers to help support and guide their hands. This technique makes it easier for you to maintain the correct arc length and to keep the torch steady as you travel along the weld seam. The torch should be held at an angle with the electrode tip pointing in the direction of travel. The optimum angle of the nozzle or tip should be between 60 and 75 degrees to the work surface. For flat welding, the torch body should be kept in line with the weld seam. When welding fillets, the body is normally angled at about 45 degrees to the joint. In this way, the electrode's tip is always pointing directly into the root of the joint. Practice holding the torch at the correct angle and the moving of the torch along a welding line. There are three basic methods used to strike an arc, namely touch strike, also called a scratch start, lift arc, and high-frequency strike. The welding machine available will normally determine the method you use. Let us demonstrate the basic elements of making a scratch start. Begin by bringing the torch down onto the metal and lay the nozzle against the surface. Note that the electrode must be well clear of the work at this time. Now, tilt the torch until the electrode just makes contact with the metal. At this moment, a short circuit occurs. Quickly tilt the torch back, at which time the arc will start as it tries to maintain contact between the electrode and the work or ground. Once the arc has stabilized, lift the torch to the correct angle and maintain an arc length of about 3 to 4 millimeters. In reality, the action is very quick from the time the electrode touches the metal to the stabilizing of the arc. The next striking method is made using a power source that has a function called lift arc or liftig. The selector control is set to the lift position. To strike the arc, bring the electrode into contact with the base metal. Activate the torch control switch and then lift the torch up. The arc will strike as the electrode breaks contact with the metal. The next method, and probably the best DC strike method, is known as high-frequency start. This method allows the arc to strike without the electrode making physical contact with the metal. Most TIG power sources will include a high-frequency selector switch. Switch this selector, HF, to the on or to the start position. Now hold the electrode about 4 to 5 millimeters above the workpiece and then activate the foot pedal or the thumb switch, whichever applies. A high-frequency arc will jump across the gap. After about 1 or 2 seconds, the main welding current will flow and the HF will automatically cut out. The procedure for striking an arc when you have selected AC is exactly the same as for DC HF start. However, for AC welding, the HF switch must be set to its continuous position. The manner in which we stop or break the arc is important. Ideally, at the end of a welding run, we need to be able to do two things, namely, reduce the welding current gradually, which will prevent the formation of a shrink crater, and maintain a flow of shielding gas upon the weld area whilst it cools to prevent the weld metal from oxidizing and becoming porous. Common to many fully equipped TIG machines is a feature called crater control, downslope, or, as on this unit, crater timer. This control is basically a timer that causes the welding current to taper off gradually when the operator presses the stop control on the torch or releases the foot pedal. On this machine, crater control becomes operational when the switch beneath it is set to the on position. Also common to most TIG machines is a post-flow timer control. We have already mentioned this control in a previous section. The post-flow control ensures that the hot electrode and the weld pool receive shielding for a selected amount of time after the welding current has stopped. In practice, the welder, when reaching the end of the run, will release the foot pedal or press the torch control switch. The arc will decay, and this action effectively prevents a crater from developing. The torch is kept in position over the weld until the shielding gas post-flow timer cuts out. If, however, you are using a machine that does not offer remote current control, then you only have one choice to break the arc, which is to raise the torch away from the base metal in the direction of travel until the arc breaks. The problem, however, with this method is that the weld pool at the point of the break-off will develop a shrink crater, also referred to as a fish eye. This feature presents a serious weakness in a weld bead. In order to avoid this problem, one technique is to tack run-off tabs from scrap pieces of plate onto the ends of your work. Breaking the arc on the run-off tab means that you don't need to worry about the crater because it won't appear in the main weld area. Having seen how to strike an arc and then how to break the arc, we next need to explain the process in between, namely running a weld. Our first demonstration will be a fusion bead. This is purely an exercise to help you obtain control over the torch and the weld pool. For demonstration purposes, we will be working with 3mm mild steel, cold-rolled plate that has been cleaned as described earlier. For convenience, we have used the ground clamp to secure the workpiece to the bench. Notice that guidelines along which we shall create the fusion runs have been scribed onto the plate. The following optimum setup should be made on your equipment for this exercise. Current type is DC set on straight polarity. Welding current set to between 80 and 100 amps. Use a 2.4mm thoriated red electrode. Fit a number 6 nozzle. Adjust the gas flow to 7 liters per minute and allow a 10-second post-flow. Before we actually begin to weld, let's look at the action that will be taken. The arc will be struck just inside the right edge, and once stabilized, drawn back to the edge. Here we must wait until a weld pool of approximately 3 to 4 times the electrode diameter has formed before moving the torch along the weld seam, or in our case, the guideline. Let's observe how this happens in live action. As soon as the weld pool develops, the torch is moved steadily ahead along the scribed line. The torch is held at the correct angle and the arc length kept at about 3mm. The size of the weld pool should be maintained at about 3 to 4 times the diameter of the electrode. In order to maintain the correctly sized weld pool, the arc length and the travel speed must be kept as consistent as possible. As we are working with a relatively small workpiece, the metal will become very hot, and toward the end of the run, it will be necessary to control, that is to say, reduce, the heat input by remotely reducing the current. Or, without remote control, you can obtain a limited heat reduction by speeding up the rate of travel and by increasing the arc length slightly. At the end of the run, stop or break the arc in an appropriate manner, but remember to keep the post-flow gas on the weld area until the gas shuts off. Inspect your work when the metal is cool enough to handle. The bead should be uniform in width and the ripples should be evenly spaced. This pattern is a sign that you have operated at the correct speed and maintained the correct arc length.